Assalamu alaikum. Welcome to Live with Hassan Akhtar. Viewers, our today's topic is from class ninth, unit number 3, name of unit logarithms. We will come to know the definition of logarithm, then its laws we will discuss. Their proof is also included in our today's lecture, and to tell you that any one proof comes mostly in the exam. We start from the definition. Logarithm of a real number. If a power x is equal to y, then x is called the logarithm of y to the base a and is written as log y base a is equal to x, where a is greater than 0, a is not equal to 1, and y is greater than 0 means y is positive. A is also positive and is not equal to 1, its value will be other than 1 any value. We note here that a power x is equal to y if and only if log of y with base a is equal to x. Viewers, the first frame is called exponential form, whereas the logarithmic form is this one, log of y with base a is equal to x. It's very interesting to make the change. Look over here first. You are given a power x is equal to y. You have to apply simply log towards this side, that is you have to write log y. Here is base a, so base will become over this side and will remain same, and on the other side only x will be left. Is it clear? That is log of y with base a is equal to x. And now if you are given the logarithmic form, this one, you can convert it into exponential. This is also interesting and easy. How? Keep the base same, shift x to this side, y to the other side, it will become a power x is equal to y. Some more information regarding logarithm. Viewers, Abu Muhammad Musa al-Khwarizmi was the first who gave the idea of logarithms. Later on, in 17th century, John Napier extended his work on logarithms and prepared tables for logarithms. He used E as the base for the preparation of logarithmic tables. Professor Henry Briggs had a special interest in the work of John Napier. He also prepared logarithm tables with base 10. Viewers, the two kind of logs will be in our discussion. There are two kinds of log. One is called common log and another is called natural log. The logarithm with base 10 are called common logs, whereas the logarithms with base e, where e is an irrational number, are called natural logs. Clear? Now we move towards the most important 4 laws of logarithms. Laws of logarithm. The first law is log mn with base a is equal to log of m with base a plus log of n with base a. You can observe here that on the left hand side m and n are being multiplied, so this law converts this multiplication into addition. Second law, log m over n base a is equal to log of m with base a minus log of n with base a. So be clear over here that there was quotient. Second law says that it converts quotient into difference into subtraction. Now what is the third law? It is log m power n base a is equal to n log m base a. Viewers, this power n becomes first of all in the start. The next is log n with base a. Fourth law I am talking about. Log of n with base b multiplied by log of b with base a, which is equal to log of n with base b whole divided by log of a with base b. Viewers, if you can focus over here, if you can learn this first of all, it will be easier for you to write the middle frame. That is log of n with base p. You can see it same over here, and at the place of denominator you are watching log of a with base p. Viewers, here is a rule that log of value is a and base is b. When you shift this total to the top place, these value and bases interchange. You can see here it became log of b with base a. We go ahead for the proofs of all these laws. So the proof of first law. Statement of first law is prove that log mn base a is equal to log of m with base a plus log of n with base a. Viewers, you need to remember this statement as well, because sometimes in exams it comes like state and prove first law of logarithm. So you must remember it. We start its proof as, we suppose log of m with base a is equal to x. Now this is the logarithmic form. We convert it into exponential form as a power x is equal to m. This is my equation number 1. And I suppose that log n with base a is equal to y. Again, convert this logarithmic into exponential. We have discussed in the very first definition. It becomes a power y is equal to n. This is my equation number 2. Multiplying both the equations, viewers, equations multiplication means left hand side will be multiplied with left hand side, right hand side will be multiplied with the right hand side. You can observe the same. A power x multiplied by a power y becomes m multiplied by n. Here the basic rule, you know, bases are same, so the exponents will be added. So upon base a you have x plus y is equal to same m into n. Now observe, this is exponential form. We will convert it into logarithmic form as we will write the word log toward this simple side. Base will remain same base and x plus y to be shifted to the single side. Now by putting the values of x and y, we are easy to prove the first law. Log mn with base a is equal to x. This was our value, log m base a in the very first step of our proof, plus value of y we suppose was log of n with base a. That makes the first proof complete. Moving ahead towards the second law. Second law says that log m over n base a is equal to log m base a minus log n base a. That is, it converts the quotient into difference as already explained. How to start its proof? It is somewhat similar to first law. That is, step 1, step 2 are same. You can observe, we suppose log m base a is equal to x, which implies a power x is equal to m. This is my equation number 1. And log of n with base a is equal to y. Converting this logarithmic form into exponential form, we get a power y is equal to m. This time dividing both equations, that is from equation 1 and 2 by division, we have a power x over a power y is equal to m over n. Here again applying the rule, base is same, so exponents will be subtracted. We have a power x minus y is equal to m over n. You can observe that it is exponential frame. You can convert it into logarithmic as apply log to this side, base will remain same, it will be equal to x minus y. Here we just need to put the values of x and y and we can reach the final result, that is log m over n base a is equal to log m with base a minus log n with base a. That completes our second proof. Looking for the next, third law of logarithms. Its statement, prove that log m power n base a is equal to n log m base a. We start our proof as, let log of m power n base a is equal to x, which implies a power x is equal to m power n. Same definition, we converted logarithmic form into exponential form and gave it our equation number 1. And you need to remember that on the right hand side, except n, you have to suppose it like equal to y. that is log of m base a is equal to y, which implies a power y is equal to m. This is my equation number 2. Now utilizing both the equations I have, that is from 1 and 2, we have in number 1 a power x was m power n, in number 2 value of m is a power y, so we replace m by a power y, whole power remains same. You know the rule, power whole power, they both multiplied. In the next step on the right hand side it becomes a power n y. Now basis on both is same. This implies that x is equal to n y. Substituting the values of x and y, we get log m power n base a is equal to n log m with base a. That makes the proof of third law complete. Going ahead, fourth law of logarithm, also called change of base formula, may come in your objectives. Statement prove that log n with base a is equal to log of n with base b whole over log of a with base b. To remember right is easy. Repeat the numerator same and shift it to the top. What will happen? Value and base, they will change. It is written log of n base b multiply by log of b with base a. B was base here, a was value here, both are interchanged. Now we start our proof as let log of n with base b is equal to x implies that b power x is equal to n. We converted logarithmic form into exponential form. Taking log to the base a on both sides, we have log b power x with base a is equal to log n with base a. Viewers here observe that it is of the frame of third law of logarithm. So power becomes earlier. It can be written as x log b with base a is equal to log of n with base a. Now here substituting the value of x, we get log of n with base b into log of b with base a is equal to log of n with base a. This is my equation number 1. In it I put n is equal to a. We have log of a with base b multiplied by log of b with base a is equal to log of a with base a. Viewers here log value and base both are same and this is equal to 1. Keep it in your mind. So we have log of a with base b multiplied by log of b with base a is equal to 1. Also already explained, log of b with base a can be written as 1 upon log of a with base b. I already told you when you shift them from bottom to top. And using in number 1 this, we get log of n with base a is equal to log of n with base b whole over log of a with base b. That completes our proof of fourth law of logarithm. Hope you all understand. Thank you very much.